Tonight, you pick up your phone before bed. You scroll for a few minutes. Then you put it down and pick up a book instead. You read one page. Then another. You don't think much of it. But something just happened inside your skull that took your species 200,000 years to make possible, and it's stranger than you'd ever guess. You were not born to read. Say that again. You were not born to read. Walking, you were born for. Talking, you were born for. Your brain has dedicated circuits for both, carved by millions of years of evolution. But reading? Reading is only about 5,000 years old. In evolutionary time, that's nothing. That's a blink. Your genes never had time to build you a reading organ, because reading didn't exist long enough for evolution to bother. So how are you doing it right now? This is where it gets strange. Your brain didn't grow a new part for reading. It stole one. The French cognitive neuroscientist Stanislas Dehaene calls this neuronal recycling. Somewhere in your brain, tucked in the left side, near the back, there's a patch of tissue neuroscientists now call the visual word form area. Before writing existed, that same patch of tissue was busy recognizing something else entirely: faces, tools, textures, the outlines of animals in tall grass. Your ancestors used it to tell a lion's silhouette from a shadow. You used the exact same tissue to tell a B from a D. Nothing new grew. Old machinery got repurposed. Every time you read tonight, you are quietly hijacking a part of your brain that evolution built for something else completely. Here's what makes that repurposing possible. Your brain runs on a principle called neuroplasticity, which is just a fancy way of saying it rewires itself based on what you repeatedly ask it to do. Every skill you practice thickens certain connections and prunes others. Reading is one of the most demanding rewiring jobs you can hand it. Think about what actually has to happen in the span of one sentence. Your eyes don't glide smoothly across the page, the way it feels like they do. They jump. Neuroscientists call these jumps saccades, tiny leaps that fire 4 or 5 times a second. Between each jump, your eyes freeze for a fraction of a second, and in that frozen instant, your brain has to do something remarkable. It converts a shape into a sound. It converts that sound into a word. It converts that word into a meaning. And it has to do all three, instantly, while also holding the previous 6 words in memory so the sentence still makes sense by the time you reach the period. You're not reading one word at a time. You're running a symphony. Now do that for 20 minutes. Every single day. That daily repetition is where the real transformation happens. In the early 2000s, a team led by neuroscientist Eleanor Maguire studied London taxi drivers and found that the hippocampus, the brain region tied to spatial memory, physically grew larger the more years a driver spent memorizing the city's tangled streets. The brain doesn't just learn. It builds. Structure follows use. And reading, it turns out, builds just as aggressively as memorizing a city. Researchers using functional MRI have found that regular reading strengthens the white matter connecting the brain's language centers, the tracks that let different regions talk to each other faster and more efficiently. One widely cited study out of Emory University, led by neuroscientist Gregory Burns, had participants read a gripping novel over several days and then scanned their brains afterward. The heightened connectivity in language-related regions didn't vanish the moment the study ended. It lingered for days. A novel, read over a single week, left a physical trace that outlasted the reading itself. Say you kept doing this. Not for a week. For years. That's where a strange side effect shows up, something called the simulation theory of reading. When you read the words, the coffee was still warm. In her hands, your brain doesn't just process abstract language. Brain imaging shows that the sensory and motor regions tied to touch and temperature light up, faintly echoing what would happen if you held that same warm cup yourself. Reading about action activates the motor cortex. Reading about smell activates the olfactory regions. Your brain, quite literally, cannot tell the difference between a well-written experience and a lived one. Not perfectly. But partially. Every time you read a vivid scene, some sliver of you experiences it. Which means the more you read, the more lives you've partially lived. Here's the twist that should unsettle you a little. This whole system, this elegant machinery that borrows old neurons for a new task, is fragile. It has to be built fresh in every single reader, every single generation, entirely from scratch. There is no genetic shortcut. A child raised without books does not develop the circuitry automatically the way they develop language just from being spoken to. The visual word form area only specializes if it's trained, page after page, for years. Skip that training, and the neurons that would have become your reading brain get assigned to something else instead. Your reading brain, the one letting you understand this sentence right now, was not guaranteed. It was built, deliberately, out of raw material evolution handed you for entirely different purposes. And once built, it doesn't stay static. Cognitive scientists studying lifelong readers have found associations between sustained reading habits and slower rates of cognitive decline in later life, alongside stronger performance on tests of vocabulary, verbal reasoning, and even empathy. Reading fiction in particular has been linked, in research by psychologists including Keith Oatley, to improve skill at reading other people's emotional states, as if the brain trains its social instincts on invented characters and then quietly applies the lesson to real ones. So, what actually happens to your brain when you read every day? You are stealing tissue built for spotting predators and using it to decode alphabets. You are lighting up sensory regions with experiences that never physically happened to you. You are thickening the very cables that let your mind's regions cooperate. And you are doing all of this with a system so young, evolutionarily speaking, that your own grandchildren's brains will have to build it from nothing too. None of this is automatic. None of it is permanent if you stop. The wiring that lets you read this sentence has to be maintained, exercised, kept alive by continued use, the same way a taxi driver's hippocampus would shrink back down if they stopped driving the city's streets. So tonight, when you put your phone down and open a book instead, you're not just relaxing. You're running one of the strangest, most demanding processes your brain is capable of. You're borrowing ancient circuitry built to spot lions in the grass, and asking it to conjure entire worlds instead. Somewhere in the dark, behind your eyes, neurons that evolution never designed for this moment are quietly, improbably, making it happen anyway. And tomorrow night, if you do it again, they'll get a little better at it.